Ladies and gentlemen, boys and girls, welcome back. Here is a quick one. We want to look at integrating, my ladies and friends and gentlemen. All right, we're going to say the integral of z4 e to the minus z. I know that I put dz. I know I put, e to the minus x in the title, and that was a mistake. My apologies. So how do we integrate this? Well, they are a product and we want to integrate using the reverse product rule. Well, there's two ways to do it. There's an easy way and a hard way. The easy way is this one. We derive one and we integrate the other and then we combine them. Have a look. So let's just say d and I. Z to the 4 will derive and e to the minus z we will integrate. So let's have a look. Derivative of z4, 4z cubed. Derivative of that is 12z squared. Derivative of that is 24z. Derivative of that is 24. Okay, the integral of e to the minus z is minus e to the minus z. The integral of that, if you decide to fix up, you bugger. Kevborn, long time. Hope everyone is doing well after the hurricane. Freaking bastard. Just loves to unfocus. Come on, there we go. All right, minus e to the minus z, welcome back, is e to the minus z, and then this oscillates, right? So the integral of e to the minus z is minus e to the minus z, and the integral of minus e to the minus z is e to the minus z. Busy with school? School, yes. Awesome, well done. I was the worst student at school, so it's good to see that you're doing better. All right, then what do? Well, we draw a line diagonally down all the way. And the question is, where does this one go? Well, it comes to the same deal. Minus e to the minus z, which is the integral of this. Okay? And the derivative of that is 0, so that's where it stops. Otherwise, it would have gone on forever because this would just keep oscillating between the negative and the positive. Now what do? Well, that we put a plus, that we put a minus, plus, minus, plus. Okay, so that means that the answer here is plus z4, right, times minus e to the minus z, and then it's minus e to the minus z 4z cubed, and then it's plus minus e to the minus z by 12z squared. My granddaughter just told me there was an earthquake in San Francisco. Yeah, I heard about that. It was very scary. There's someone filmed it live on Periscope. It was, in Mexico, it was massive. Buildings were shaking, people were running around, so that one is probably interesting to watch, but it depresses me, so I just do mathematics. All right, so as we said, it's plus, but plus of minus e to the minus z by z4. 2 though. I didn't, sorry, I saw Mexico, I didn't see San Francisco. I think I said yes. So it must have been, there you go. Went all the way up the San Andreas Fault, clearly. And there's a massive fault line as well between Mexico, Central America, and Texas. So yeah, I can see Middle Eastern news right now. God has passed judgment on America and Mexico. All right, minus e to the minus z 24z plus, and that's a negative, minus e to the minus z by 24, and then at 0. All right, so here is the answer. The answer is right here. All of these have a minus, so this can be simplified. That can be minus e to the minus z outside. In a text, she's far away upstairs. Crazy. Tell her to get outside of a building. Goodness me. Z4 plus 4z cubed plus 12z squared plus 24z plus 24 plus some random constant of integration. Fault line jihad. Yeah, talk about it. Can you do a run over of error propagation and absolute uncertainty? Sure. Which subject is that? Are you talking about what I did before with the Heisenberg uncertainty principle? So there's the answer. Hey, Haddadi is back. So the integral of this is actually this. Am I actually right? Yes, I am. So now what I'm going to do is I'm going to do it the long way. And the long way is using this formula. Good memory. Hey, can't forget Haddadi to vote on that comment. So touchy lately. Crazy. Yay, plus C. That's right. I remember you're my teacher, man. If you test on it tomorrow. Do you have a question? If you have a question or like a practice question or something, send it through to me on Facebook at Gabsmacked, and I'll do a scope on it. Am I Lebanese? I am Lebanese, yes. Australian Lebanese, my friend, citizen of both countries. Okay, so let's try it the hard way. The hard way, the integral of u dv, that's gone out, equals u v minus the integral of v du. Okay, so dv is the derivative of v. V is obviously the integral of dv, and then v is the integral of dv. Du is the derivative of u. Pretty straightforward. So now let's try it again. So u in this case would be z4. So therefore the integral of z4 e to the minus z dz. So this part here would be dv, and this part, so this part is dv and that part is u. Okay, so just plugging it into the formula, we're going to get, what's u by v? It's going to be minus e to the minus z by u, which is z4, minus the integral of v du. Now v is a negative, so negative is positive, so e to the minus z, and du is 4z cubed. So you can see it's already working, because we have the first term, which is that z4 and minus. Are you into programming? I don't like it that much, but I am quite proficient at mathematical programming, yeah. That's part of what I have to do next year for gravitational waves. And the integral of this is going to work out to be the next term, which will be that, and then that, and then that, and then that. So it's actually going to be the same thing. But this way is longer because we have to integrate this, and then we'll be left with another integral, which you have to integrate, another integral, which you have to integrate. We keep going back until we get 0, and then we end up with this whole term. So just going over it again, the easiest way to integrate to when you have the exponential and a polynomial is by doing this. You derive one side, you integrate the other, and then you just draw it down, and each term, the first term is a positive of whatever that term is. So this term happens to be negative, so a positive over a negative is a negative. The next term was a positive, but we always make the next term a negative, so that becomes a negative. And then the next one's positive, but that's negative, right? So they all end up being negative, and then you end up getting this. Otherwise, you'd be here for years, man, trying to solve this problem. So I'll show you another way. There's another one that's going to be even harder to integrate. Have a look at this one. What is the integral, right, of sine x cos x dx? All right, that's going to be an interesting one. Excuse me while it loads. Bastard. Sorry. Okay, if we do it one way, have a look at this. If we say we put derivatives here and integrals here, so derivative of sine x is cos x, and then the derivative of cos x is minus sine x. The derivative of minus sine x is minus cos x, and the derivative of cos x is sine x. So we keep going backwards and forwards, and here cos x, that's going to be minus sine x, Dr. Sexy, and then minus sine x, derivative of that is going to be minus cos x. Derivative of that is sine x again, and derivative is cos x. So, and then we join these, and you can see that it actually goes forever. It could keep going. So the answer will be, what's that? Negative sine x squared minus cos x squared. It's a lot of x. And what do we got here? And then minus sine x squared what are we here? So that's positive, negative. So that becomes plus cos squared x. And it keeps going forever, which is very strange. So how do we actually solve that? We can't solve it this way. We have to do it this way. We have to do it the other way, which is uv minus the integral of v du. So the integral of u dv equals uv minus the integral of v du. And there's a little trick here that you'll see, right? Because this will also go on forever. But have a look at this. Have a look at this. U, okay? In this case, u is sine x, right? So du, so therefore du, okay, is going to equal cos x, okay, dx, but d2u, the derivative of the derivative, is going to be minus sine x u. But d3u3 is going to equal, what have I done here? Cos x minus sin x. Yeah, that's right. Sin x, cos x minus cos x. Minus cos x d3x3. So, which happens to equal minus du. So it keeps repeating itself. So what happens is that you'll end up getting, let's actually do it. Let's solve this bad boy. So that equals uv, right, which is sine x, and the integral of cos x is negative sine, sorry, hold on, what have I done here? The integral of cos x is sine x, you bastard. I stuffed this up. Whole time made a mistake. What a bastard. Okay, so sine x cos x, and then minus the integral of v du. Now v, which is the integral of cos x, is sine x, and du is cos x. So that's going to be the integral of sine x cos x dx. Now this is the weird part, right? Have a look at this. Sine x cos x, the integral of sine x cos x is the same. Integral of sine x cos x, right? So that means that the integral of sine x cos x dx equals sine x cos x minus the bloody same integral that we started with. So if we put this back on the other side, that means that 2 by the integral of sine x cos x dx equals sine x cos x. Now, I bet you I've made a mistake somewhere. uv. I have made a mistake. Fuck, I made a mistake. I'm going to start again. Damn it. Always making mistakes is the important part in particular here. Yes, you are absolutely right. As always. Okay, so let's start again. Integral of sine x cos x equals uv. So u is sine dx, sine x, and v is sine x, so sine squared x, minus the integral of v du, which is sine x cos x dx. Okay, now we're getting somewhere. Okay, so it is the integral of that minus itself, right? So then we say that, therefore, 2 multiplied by the integral of sine x cos x dx equals sine squared x plus c, and therefore, well, you can call it whatever you want, but the integral of sine x cos x dx equals half outside of sine squared x plus c. Okay, now I'm going to test it by deriving this bad boy. Okay, so let's derive this. So let's test. So we have half of sine is akin to spotting a unicorn. Oh, I make math errors all the time. There are many unicorns around here. It is one horny farm with all of the unicorns. Okay, plus C. And I don't mean that in a dirty way. I mean that unicorns have horns, so there's lots of horns. Okay, so we want to derive d dx of this equals, okay, d dx of 1 over 2 outside of sine x by sine x plus c. I just expanded that, okay, which equals, did Kev Bourne send me that question on Facebook so I can answer it? I think he'll come back and send it to me. Lots of accidental innuendos. Oh, how convenient. All right. As convenient as many horns. All right, so then we want to derive this, which equals the root of the first by second, second by first, and that disappears. So first by the second, which is cos x sine x, plus the root of that, which is cos x sine x, and it's a half out the front, which equals cos x sine x, which equals the top, sine x cos x. And there you go, my friends. We have solved the equation. I hope that some of you here have actually been able to follow what the hell's going on. So just to go back to the front, you can see that this is one way to derive. Thank you very much. And back to the original. Z to the power 4, e to the minus z. Integral of that, we can do it this way. We derive one side, integrate the other side, and then match them all up. Plus, negative, plus, negative, plus, negative, and you get this. The other one is to use this equation, uv minus v du, where uv is u is u, obviously, and me is me. Hilarious. I do that every time. V is the integral of dv, minus the integral of v, which is integral of dv, by du, which is derivative of u. And then you get the answer. One will work sometimes, one will work another time. As you can see, I've showed you two examples where this one is better for this one, but for the sine and cos, it won't work. You have to go and do this one. And then there's a little trick. You know, like when I was first doing my maths degree, to figure this out, man, this took me ages, because what I kept doing, I kept integrating this and integrating, and I didn't even realize that this term was the same as this term. So I could have just put that there and solved the problem so quickly. So there you go, ladies and gentlemen. The gab is back, and that's it. I have been able to construct this wave today, which I haven't showed you because the maths is too complicated and I didn't want to bore everyone today, and I couldn't be bothered teaching. But I was able to construct mathematically these three waves, which was a lot of fun. Where are we? This one here, which was a simple one. This one was a simple one. And I did this one, which was a little bit more complicated, and there's an inverted version of this. Claricus is back. All right, and how to solve those, basically what we do is we construct, I've already shredded the papers. Let me see if I can find the formulae. What we have to do, you like those waves? Yeah, what we had to do is we have to construct the waves based upon mini waves that are not even in this universe, right? So these ones pop into our universe. Trying to get Periscope working on my computer. I didn't know you could do it on a PC. Oh, actually, I've done it on a PC, but I use my phone with it. All right, so here, right, these are the hydrogen radial wave functions. So this means that when the radius of the sphere of hydrogen, right, it pulsates in and out, hey, and it depends on the energy level. So that's the radius. And here is the actual function itself. You can do it anywhere, wink, wink. Yeah. So what I had to do was I had to get the radial function, and I did a Periscope on this like 2 in the morning or whatever it was a few days ago, if you want to have a look at that one. And I did it without maths at all. I just got a little globe and showed you how the function works. So you can have a look at that. That's about it. Unless anyone has a question, I am going to go and do my next question, which is constructing the 4-dimensional wave. I'm up to 4-dimensional waves. I'm very excited. And you can't see these we can't see these, right? So what's interesting, I said this yesterday to Melissa Sara. I'm going to leave this thought with you guys. People think that the universe is 3D and we're traveling through time. No, the universe is 4D, but so are we. So the future and past already exist, right? It's like a book, okay? So if you're reading a book such as, you know, The Tragedy of the Retarded Genius, what is the mass of a shadow? Hey, hey, hey. All right. Your future self is reading the future part of the book, which means that the book is being read in 4 dimensions all at the same time. Your future self is reading one part and your current self is reading another part. And so our future self already exists. Our future self is dealing with the future part of the universe. We just think we're traveling through time or it doesn't exist. I mean, you can see it both ways, but that way mathematically is the way I see it. It makes much more sense that way. Because the universe is one solid 4-dimensional object. And so the universe has an edge in 4 dimensions, but not in 3. And I guess the best way to think of that is like being on a balloon, right? If you walk on a balloon, you'll end up just keep going around and around and around, right? So that's about it. None of that's actually provable at the moment, but mathematics tells me that at least. And all the best. Until next time, where facts don't care about your feelings. Go get the damn book if you haven't gotten it. Go get the audio book if you haven't gotten it. Old lady watching my life as a movie. Yeah, pretty much. Pretty damn much. Go to the Pompous store if you like. Bye-bye. Oh, it said wait. What am I waiting for? Kev Warner's like, wait. What do you want to do? Oh, sorry about the lag. Sorry. What's he saying? What's he saying? What's he saying? What's he saying? No, not there. He is there. I'm not sure. All right, just go to my friend. Where can you message me directly? Just tweet me directly at Anautist, ANAUTIST. If you tweet me there, whatever the question is, I will and can you go over error propagation? Sure. You just got to give me some examples and I'll do it for you. All right. Talk to you all soon. Facts don't care about your feelings.